Hey everybody, welcome to another episode of TechArt EDU, where I, Chris Rhoda, I'm here to bestow upon you with all of the mysteries, the solutions, that is, of what it means to be a tech artist. So today I'm going to give you a quick introduction of a concept called Pixar USD. Now, this is from Pixar, but it's now open source. The Kronos Group is managing it. It's called Universal Scene Description. And what this is an intermediate format in order to describe virtual environments. And I'm super, super excited about this. And I really think that this is going to be the future of all CGI. Now, right now, it is taking the online rendering, the visual effects world, the film world by storm. It is a great way of making things available for multiple departments and multiple companies to work together on the same assets. But I see this as something even bigger, and I'm going to give the basic introduction today. A little bit of show and tell, if you would, on how this sucker actually works. All right. Let me get going here. Aha. Yeah, so I call this USD and Omniverse because actually USD is one thing and then NVIDIA is kind of jumping onto the package. They're kind of jumping onto the bandwagon also, and they're kind of like bringing and helping manifest this kind of USD-ness, and they're really pushing the concept along anyway. But it's a steam locomotive, in my opinion, that's going to bear down us, and it's going to change everything that we know about CGI. Or we could call this Pixar and NVIDIA's attempt to create the one ring to rule them all. I don't know. You tell me after this session here. All right. So, all right. Let me get this going here. Okay. Very cool. So, what is USD, or Universal Scene Description? Well, it's a Universal Scene Description file format. It's a way of describing an entire scene, and it could be as small as a sphere on a plane, or it could be as large as an entire world. And it is all broken up into one file or an unlimited number or an infinite number of files. And it can contain geometry, it can contain animation, lights, cameras, shaders. And you might be going, oh, well, FBX, does all this. And yes, it does. However, FBX has got its problems, and two of the big problems is that it's a black box. Autodesk maintains it, and they're always changing the version, and whenever they decide they need an update, they make an update, and it makes everyone else conform to them, and that is a royal pain in the ass. And two, well, the Autodesk controls it, and no large scale respectable CGI company would allow their primary blood, which is their intermediate format, to fall into the hands of a third party operator, which they can't control. But they actually can do this, all of this, with USD. And so what USD does is it multiplies and it layers lots and lots of different files on top of each other, and it creates lots of little layers, kind of like in Photoshop. And you're saying, so what? Big deal. Okay, it's one scene format. What this powers is greatest artist collaboration. So if you got USD, and then, like I said, NVIDIA's jumping in on this, and they created something, well, they're working on something called Omniverse. They haven't released it yet, but I really believe this is going to define what all CGI production, multimedia production is going to look like into the near future. And I do believe this has infinite opportunity, and I'm really jazzed about it. All right, here is a quick video created by NVIDIA showing an entire scene created entirely in USD by artists and programmers and designers from around the world. And they did this to create a one particular environment in video, and they wanted to show this off, how they could render off their RTX stuff in real time, which is actually kind of nifty in and itself. But knowing that there are literally millions of little objects in this scene, and you understand how long it took them to put together, which was a relatively short period of time because they were able to distribute the course load through hundreds of artists and designers and programmers all over the world. And they were all able to contribute all this to this at one time. And because this is going to be ray traced, you don't have to worry about rasterization. So therefore, you could get very, very large scenes into into an environment very, very quickly. So let's take a look at the video. Oh no. Go back, please. Okay. Oh, here we go. Yay. I have to admit, I get goosebumps every time I watch this. Just to know that this was created with ray tracing. Just it's so cool. Maybe it's nostalgic, from having grown up in the 70s and 80s and actually having played the game that which is referenced to is also really nostalgic. Now, this is a recording, but it was recorded in real time, live, and is using one RTX renderer on one machine. Kind of familiar. Remember in Toy Story 4, in the curio shop, in the junk store was put together in the exact same technique. All right, really, really, really fun stuff. It really get me going on this. Okay, so a USD file is contains, one thing, and it can contain a lot of different things. One of the big draws about USD is that you could devote one particular scene or department file to a specific department in your CGI company, and all the departments could work on together. In this situation here, I have this entire project or this level, and then it's broken up into multiple little scenes. There's multiple animations, there's effects, there's lighting. All of these have their various components that are devoted to it. And they can all work on this non-destructively. Okay, the reason why it's non-destructively is because nothing gets destroyed in USD. Stuff gets trumped and prioritized more than others, but it never, and which means the objects get turned off, but objects are never actually clobbering each other, which is like really awesome because it empowers all the departments to actually see the same thing. Now, some of the components of a USD file is a layer, which is basically a single file on disk. And a stage is the resulting layer composition of that. And there are a lot of different ways of putting that together. Now, I don't really have enough time to go in through all this composition arcs, but one of the big ones is a sublayer. And a sublayer allows you to just kind of put things together under one big old namespace. And if you look at the / here, that is kind of like the old Unix forward reference or the top root layer. And that is and everything beneath that root layer is considered as a sublayer. And I'm going to fast forward through this, and This is all very interesting, but I'm afraid we just do not have enough time. But when objects start clobbering each other or start forming others, they have a very elegant technique called opinions. And opinions allow certain USD elements or certain USD layers that were placed higher to actually rule the day. So, in other words, the highest dog wins, or the last one entered is going to be the one that wins, and it maintains the priority. But that does not necessarily have to happen, and it can be adjusted. So that's where it's really cool. Now, sublayering is where you can get fixed scene graph locations, and you can put one sublayer per department. And once again, your department guaranteed isn't going to be collaborating the work of another thing. Now, referencing is another way of bringing stuff in, and referencing is a way of actually like grafting an entire area or scene or level onto another scene or level. So you kind of like just graph the whole thing together. And that's really good. Now, payload is another word for a USD file that contains the actual geometry definition of there. This is the actual content of the thing. This is where the materials are stored. This is where the data is actually stored. And when you're dealing with millions and millions and millions of objects, this is like way down into the pipeline and way down into the thing, but it's kind of managed away from the structure on things so that only the data that you need is loaded when you need it, and nothing else is grabbed along the way. All right, instances is kind of another way of that, is that the same object does not necessarily have to have the exact same definition. It depends on the context in which you use that object. And in my humble opinion, this is one of the most important USD features, and this is going to be the key factor for using USD in order to define entire worlds. Now, I do mean entire worlds because you can define entire worlds now with USD, which is something that you couldn't do with an FBX file. Now, a variant set is a component inside of an asset that allows multiple definitions of one object to contribute towards it, and basically turns a USD object into a smart object. And it means that it can have multiple modalities, multiple states, multiple variations, and they all can coexist with each other in a very happy way. All right, one of these ways that I don't have enough time to show you is a way of storing LOD generations. So for one object, you can have multiple LODs. When I was working on Madden, and I'm sure Juan Sepulveda can appreciate the pain, and we did was when we created the crowds for Madden, we had to create 7 LODs, and it was a royal nightmare. So we went down from 20,000 polygons all the way down to 12 polygons in LODs, and it was royal difficulty. But with USD, you can store all the LODs in one location. You can store all the LODs together. You can automatically generate them if you want to use something like Houdini, and you could separate, identify parameters within the cameras that will automatically identify on when camera ranges will actually switch LODs. Really, really awesome stuff. Automatically. Okay, aging is another issue that we were always trying to do in Madden. Because during a football game, the football players will start off looking in great shape, and then by the end of the game, if it was a real bloodbath, then there'd be blood and mud and wetness and sweat, and their jerseys would be torn and all that other stuff, and we just couldn't figure out how to get that done. But you can start off with an initial state, which is just all copacetic, and then add additional states that go ahead and kind of age the object over time, and until you can create one final decrepit object. And all these objects exist within the exact same object, all the same. They're all basically the same. You can control which variation that you want, or which variant. All right, Hydra is something that you're going to encounter a lot, is that using USD, Hydra is the API that all local renderers have to conform with if they want to use USD. So that means everything that produces CGI elements has got to produce a Hydra delegate in order to visualize a USD scene. And this is really cool. This is like totally amazing because this is like with one viewport, you can have many, many renderers. If you wanted to go into the real time, you can have an OpenGL or Vulkan or DirectX display port. You can have a UE4 or a Unity display port. And at the same time, you could also be looking at RenderMan or Arnold or maybe um, Maya or Blender or Katana. Any of these possible renderers can all be seen at the same time, and you can all take a look at them, and they'll all be showing the exact same thing at the exact same time, and they can work co-work with each other all at once. And everything is going to be live rendering, and this is where NVIDIA is coming in because NVIDIA sees the opportunity as for them to be the kind of like big dog to kind of push this along. Now, Omniverse is broken up into 5 sections in itself. And then at the core of it all is the nucleus, which is a great big storage in the cloud that stores all of USD data. And it uses USD to define it all for the description language, and it also is developing something called the MDL, which is Material Description Language. Will this replace HLSL or GLSL in the long run? I don't know. Who knows? We'll have to see what they're up to. This is all still in development. They haven't released it yet, but these are one of the concepts that are still playing around. And so that everything in the world is going to now be defined as USD and MDL, and everyone will understand what it looks like, and it's going to look exactly the same on any display device. This is kind of like what it looks like altogether. You have Omniverse in the center, and you have all your UE4, your Unity, your Maya, your Blender, your Substance, Photoshop, and this is all feeding stuff to the Omniverse. And each one of these little plate dealios is like a delegate, or I'm sorry, a subscriber to Omniverse. And so they're all talking to Omniverse at the same time. And as soon as a prescribed service or a object is updated inside Omniverse, then the updates are sent immediately to all people that are, or all critters that are prescribed to it and so forth. So this is like a really amazing way of looking at it. Now here is a video that shows Omniverse in action. Now this shows 4 different sequences all working at the same time. This is within the NVIDIA Omniverse itself. This is what NVIDIA sees. This lower one is what the artist in Maya is contributing. This one looks like Substance, and this one looks like UE4. And all 4 of these folks are working on the exact same scene at the exact same time. One way to think about this, as long as every department or every artist stays within their particular swim lane, everyone can collaborate at the same time, and they can contribute to the overall functions and get some really awesome stuff going all at the same time. Now this is like crazy means, because that means that you have companies that are here in the States, and you could be working with outsourcers at the exact same time, looking at the assets that they're creating in the context of your situation. Now, this is like has huge implications for online application. Okay, cool. Another aspect of Omniverse is Connect. Now, this is the actual library that hooks into whatever DCC that you're using. Now, this could be anything that displays CGI. And NVIDIA is trying to do this Herculean task of creating these plugins for each of these DCCs. And they're trying to maintain it. And they're going to evidently keep track of all these things, which is like an amazing task. I don't know. In my humble opinion, I don't think NVIDIA is going to be able to keep up with this because business-wise, that means that they're going to be coming into the Omniverse maintenance business, and which is not what they're doing. Actually, they're getting into AI, which kind of like is contrary to what their direction is. So I don't believe that this is going to be the final way that NVIDIA is going to go, but I could be job because this is not a petite job. It's like kind of gargantuan. Now, Omniverse Kit, it's a toolkit they provide, they'll allow the individual to actually create content within using USD and Omniverse. And so instead of actually having to use a separate DCC in order to pull stuff together. You can create your own DCC and you can create your own departmental and company-wide gizmo in order to pull together your scenes and put together things before things. And it totally independent of DCC. And this is like really, really powerful, and it really gets things going. Now, one of these things that it can do is since this is Omniverse is up into the cloud, they offer microservices that are thing, and one of these microservices is physics, where the simulations can now be done into the cloud in real time. So therefore, you can create dynamically, you can call for simulations to be constantly generated and computed up into the cloud in real time, and that be sent down to the user in real time. Now that's really cool. I personally, I don't see how effective real-time simulation is going to be into the entertainment world or the simulation world, whether that be in real time, in film, games, simulation, or theme park construction. This is pretty much used for a big data representation or big data interpreting and big data AI kind of representation. Now, Omniverse, because this is NVIDIA, this is all going to be RTX. This is all real-time rendering, and it's all supporting Hydra delegates. So that means if you're going to be working inside of USD, you're going to be using real-time ray tracing. And the reason for that is no rasterization, and you can have extraordinarily large scenes going on at the same time. All right, I've got a whole bunch of links of where you can actually start getting involved with this stuff. There's a lot to learn. I mean, too much for any one lecture. This is actually a sequence of lectures. I would love to actually explore this with you folks. If you are interested in hearing more about USD and actually having me give more lessons during the Tech Art Talk time, please get in contact with me. Hit the subscribe button over here. Yeah. 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 Oh, yeah. Okay, there it is. Yeah, hit the subscribe button. Respond back to the discussion. Talk to me. Um, Go to the TechArt EDU webpage on Facebook. Go to you send me email, chris@techartedu.com, and tell me if you want to learn more about USD. I am super jazzed about it, and I really think that this is going to be the future of where things are going. I don't have a topic for next week, so it will be a little bit more of serendipitous. We'll have to see what happens next week. But thank you very much for joining me and allowing me to gush all about USD. And I hope you guys have a great week, and I'll see you next Friday on Tech Art Talk Live.